I just received this B&K500 I bought on eBay, and I'm starting to take it apart, taking out all the screws around the outside. And now I'm going to lift out this panel right here. Now I've actually already disconnected it underneath so it will lift out. There's the connector that connects down there, and I've marked it with an R for the right side and an F, so I'll know that it goes back in this orientation with the two empty pins on the right. And I'm going to set that one aside, and now I'm going to take out the screws that are down in there. Oh, there's a little panel right here that also has to come out. It's just a little filler panel to fill the space between the test panel or the socket panel and the control panel. So I'm going to do that, and I'll come back after I've gotten that unit out of the bottom there. And now I've taken out the screws there, and now this whole panel should just lift up and right out of the unit. I'll set it right over here in this chair while I put this piece aside. And obviously it's going to need a bit of work. It's cracked open there, and in general it's showing its age. Of course, so am I, so I'm not going to be feeling very haughty about it. Just a question of how can we fix this up and make it look like the nice tester it once was. And now I've turned it over, and it looks, from the lack of nuts on some of those screws down there, that I guess my case just fell over. Yeah, I guess it did. Well, anyway, that somebody has replaced this meter, or at least has taken it out, and when they put it back, they didn't put all the nuts back on it, because there should be nuts on that screw as well as that one. But we'll see. In the meantime, what I'm going to do is, if you've watched any of my other videos on restorations, you know that one of the first things I do is short out the meter, so that nothing I do can accidentally drive a current through that meter that'll burn out the coil, because those are the most valuable thing in these testers generally, that and the transformers. So now I think what I'm going to do is assemble the literature I have on this tester and put together a plan. Well, there's a few preliminary conclusions. One is this wire obviously is supposed to be connected somewhere. I'm going to assume it's probably on that bulb there. And you may notice that that bulb is out of socket because it's also bad. It's a type 44, GE number 44, so I'll have to go get one of those out of my stash. And I'll undoubtedly want to replace those capacitors, and probably just replace everything in here that's stationary, like resistors and so on. Obviously I'll try to keep the pots and that kind of thing. Replace the selenium rectifiers with silicon. The fuse is still good, so that's of some value. It means that either nobody has tried to turn this on, or if they did, at least it didn't draw so much current that it blew the fuse. And obviously we'll have to check those tubes. The one on the left is a 6AX5 and the one on the right is a 6AT6. Someone obviously has worked on this, I assume, because they've written I guess the capacitor numbers on there, 12, 13, and 14. Now I have to check those with the schematic. I assume that someone did that after this was shipped from the factory. They could be factory markings, but I doubt it. They do look like the original capacitors, however, so obviously those things are as old as I am and need to be replaced. So we'll get back to that after I've assembled some parts and pulled together the schematic and the the parts lists and all of that. Before I start too much restoration on this B&K500, I want to test out the transformer. If you watched my series on the B&K650, you know that the numbers on this schematic on the right hand side, like the pin 12 up there that says diode plate and so on down, correspond to this connector, which is where the socket panel connects. That is the panel on which all the tube sockets are located. And this is numbered starting on this end with number 1, the one that's away from you. It goes down here. Then it starts back here. Now you have to be careful, because if you're used to numbering systems like on dual inline packages, the so-called dip sockets, when they get to the end, they kind of wrap around in their numbering and come back this way, so that 1 is here, and then whatever this is, and then this is the next one, it comes back, and this is the highest number. This socket is not done that way. This is 1 up, and then comes back here to pick up. So this is the highest numbered socket. So I'm going to be using these pins and a few other test points to check out that transformer. Okay, I've connected the meter to pins 2 and 3, which, as you see there, are labeled heater. And as you follow them over here, you see that one of them goes to the base of the winding, and the other one, this winding, goes up to the switch. And of course that switch is right up there. And so what I'm going to be doing is turning this switch and watching the meter. Now you may notice that it's right now reading about 15 ohms, which is generally, in my experience, about what the 50 volt reading is. And that's where this heater is set right now, is to the 50 volt range. So as I'll turn it kind of like this. As I turn this down, I hope you can see the meter drop down to very close to 0 ohms when it gets down to the lowest setting. So what that tells me is that the heater windings on this transformer are good. I already know the primary is working, so the next thing is to check the high voltage windings, which, coming back over here on the schematic, you see are there's the winding for the bridge and for the 6AX5. I'm sorry, the 6AT6 that is actually used for the for gas and grid emission tests. And then there also is a winding here that goes to the rectifier, which in this unit is a 6AX5, not a Type 83, and I'll talk a little more about that in a minute. Similarly, there's a winding that goes to the other of the rectifier, and what I want to do is make sure that those windings are all good. And after I've done that, I'll come back and we'll maybe start some restoration if the news is good from the transformer. Okay, I've checked out the heater windings as I indicated, and I've begun checking some of the others, but I thought I might point out something about this particular B&K500. You notice someone has written down there 6AX5 by that socket, and that is correct. In the later models, it uses an 83 tube, and that's what was on there originally. What I've done is I've relabeled that tube as a 6AX5 based on the RCA tube manual. You notice, for example, that the the filament is 2 and 7, so I've relabeled 2 and 7 there. And this happens fairly frequently. This is an old B&K500. It's from the first production runs. In fact, there's a serial number on it here somewhere. I guess it's right there that says 2280. And so this was among the first 3,000 that they produced, and they produced a lot more than that. So at some point they changed from using a 6AX5 to using an 83, which is 6AX5 is a vacuum rectifier. An 83 is a mercury vapor rectifier, and in most of the tube testers after this they used the 83, which was used because it had a lower voltage drop and a little more consistent voltage drop from each of the plates to the cathode or filament. So this circuit is a little different. I also will point out that the wiring down here is different, in that in this Model 500 a lot of these resistors that come back here and go down and back out this way are just a single resistor from this pin to this pin, and the value is equivalent. The circuit works pretty much the same way, but once again there are circuit differences in this unit based on some, apparently this was the early circuit, and later they switched to a slightly different arrangement. It works basically the same, but you have to be careful when you're testing that you use the circuit that was actually being used in the model or the serial number that you're working on. So I'll get on with it and finish testing out the transformer and all of its connections to both the 6AX5 and the 6AT6, as well as to the bridge circuit, which is right over here, and to the selenium rectifiers, one of which provides screen voltage and the other of which provides the bias voltage for the set. So once I've finished that, I'll come back and we'll see whether it's worth working on this tester any further. I've finished checking out the transformer. Seems to work fine. There is one thing I thought I might show you though before I go on to start replacing capacitors and these selenium rectifiers and things like that. You notice there's a wire here labeled orange that goes to the two selenium rectifiers, to the negative lead of one and the positive lead of the other. And that orange wire is this wire right here, which you can see looks pretty orange over there. But as you may notice, it's starting to turn color, and so right there it's orange, but there it starts to look yellow, and that's just from age. The wire comes over here, and over on this side the wire looks like a yellow wire. And so once again you can get fooled by that. In a lot of old sets the colors tend to fade badly, so don't depend necessarily on the color code unless the wire has been protected in a way that keeps the color from fading. So like I say, the next thing is I'll be replacing those three electrolytics, I'll be replacing those selenium rectifiers, and then we'll probably be ready to start testing this unit out. It looks like it might be worth bringing it back to life. Okay, I've cleaned the contacts on the switches with deoxit, and I have replaced the selenium rectifiers with those two silicon diodes you see down there. I took advantage of an extra pin that's right in the middle there where that yellow wire connects to, this one right here. It was spare, so I just used it and removed the yellow wire from the place where the two seleniums connect to each other there. I've also, of course, replaced those electrolytics, And so now I'm ready to bring up the voltage and see what kind of voltage I get. Bring it up to about 115 volts or so. And you see over here, I'm getting 160 volts on the screen connection. It's right there. And then I'm going to move over and check the bias supply. You see I'm getting 151 volts. Now what I've done is I've actually been searching around for a better schematic, and I finally found one of this version with the 6AX5 instead of the 83 tube. And then this is a version of that same schematic but with some voltages written on it. And you notice here it says the screen should be 155 and the bias should be minus 150. I'm referring to this notation right here and to this notation right there. Well, my bias is minus 151, so that's pretty close, but my screen is a little bit high. You notice it's reading about 160. Now, I don't know what line voltage. Oh, it is taken with a 20,000 ohm per volt meter, so that might load that down a little bit more. That's an 11 meg input, so I may recheck that with a 20,000 ohm per volt meter. You see right here. But at any rate, I'm happy that I finally got a schematic that represents the unit I'm working with. And by the way, you notice it does if you compare this one with this one. You see on this one there are those three resistors there, and I said that on mine they were all back over here. Well, that's exactly right. You see there's no resistors there. They're all back over there. So I think that I finally found a schematic that I can use exactly as it is, and it looks like that my voltages are starting to come up correctly. Also, the bridge lamps are burning. That's a good sign. I had a bad bridge lamp, a number 44, so I took the number 44 out of the pilot light, which is right up there. So these are original number 44s as came with the unit, but one of them is actually the one that's been in the pilot light socket. So now I'm ready to move on and start testing the tube tester itself. By the way, you may notice that in order to test this, because I didn't want to cart the socket panel over here. By the way, this particular panel is called the bridge panel. You see right there. And the other one is called the socket panel. And the socket panel, as you remember, plugs into that connector right there, and the AC power comes in through there. So what I did is I just soldered a line cord onto the pins 13 and 14, as you see right there, and then connected that over to my Variac. Actually, it's not a Variac, that's a trade name. It's actually a variable isolation transformer. So with that, let's move on. I think I've finished replacing all of the capacitors in here. I also replaced this 0.005, and I put a capacitor across the meter that's shown in this schematic there, and the parts lists indicate that it should be a 250 microfarad. Now that's C5 there, 250 microfarad, 6 volt. I used a 220 microfarad that actually measured about 230, 10 volts. I measured it on the the Zencore LC102 there. But what I've also been doing is using this new schematic that I found and marking up a series of voltages off of this schematic, which is the same schematic but a much worse copy of it. And now what I'm going to do is I'm going to transfer this information about the function switch over to the schematic so that I have one complete schematic with all of the information on it. The point is I'm trying to put together a manual of all of this. I have some of the manual, some of the operating manual here. I've disconnected the power cord that I've been using to power the unit. It used to hook to the 2 pins over here. And connected the socket panel and of course the AC line cord, which you see here, comes through that. So now the unit is connected as it normally would be. But now, I think I told you this on-off switch is really messy. It sometimes stays and sometimes doesn't in one position, but even when it stays, it does not make good contact. So I'm going to be replacing that switch with this one. It's not an exact replacement, but it's pretty close. Has the same feel, and so and it has the rating that you need, which is, you need to be careful because some of these are not rated for AC for 125 volts or whatever. So make sure that you get a switch, if you're going to replace your power switch, that can actually handle line voltage. So I'll do that, and then I'll come back, and I think I'm going to be ready to start checking out the functions of the unit, GM, shorts, things like that. Power switch here. I also installed a new number 44 bulb. If you remember, the one of them had burned out. It actually was over in the bridge circuit, but I wanted to use the bulb from here because it's the same age as the one that's in there, and that helps to keep the bridge balanced using two bulbs of the same age. So now let's see if it turns off, and it does. So I think that cosmetically, or at least I should say mechanically, I have completed the restoration. Now it's a question of checking functions. I need to get a knob for that switch there, and then we'll run through basically the calibration procedure, and if it calibrates, that also means that the function is working, so that's the next step. I've been working mostly on the circuit associated with the meter, mainly cleaning this sensitivity control and checking the resistors around it and so on. And I'm now happy to report that I can test a tube. You notice the meter there, and then of course the sensitivity control varies the reading, and you pick the reading based on the tube. And I have this panel turned upside down, otherwise I'd show you on that side. But what I can do is show you the tube chart that I printed out. This is one of 2 pages. And you notice, well, for example, let's take say a 6W6. You put that in socket 8B, put the filament at 6 volts, adjust the sensitivity control to 18, and it should read good, bad. if you set the sensitivity control to 10, then it should read 8,000 on the GM scale. And you notice that's this scale in here, not the red, yellow, green, but the scale down below in micromhos. Now actually the tube I'm testing right now is a 6AL5, but which is just a dual diode, so it doesn't have mutual conductance. It's just tested for emission. But at any rate, I think I've now gotten all the functions on this working. You may remember I worked on the shorts function earlier and got that working. Now the GM. The life test is basically reduces the voltage. I'll switch to that. And you see that the meter reading begins to drop, because what it does is lower the effective line voltage. And you see it, so if this tube tested good in the GM position, right there, and watch, you see the emission goes up into the good area. But when I go to the life test, it drops the voltage down, and you see it immediately drops off into the questionable and near the high end of the replace range. So that's basically how the tube tester operates. I'm going to be doing a little bit cosmetically to it, and then I'm going to be working on the case to put this in, and maybe that'll wrap all this up and we can move on to something else. But for now, I think the electrical operation of this unit is complete. And by the way, I might point out, if I haven't already, those two bulbs right there are part of the bridge circuit for the meter that attempt to compensate for line voltage variations. In other words, if you operate the set at 115 volts, and that's where it's calibrated, then say the voltage goes up to 120 volts, well, that those two bulbs in connection with those resistors form a little bridge that reduces the signal voltage a little bit as the line voltage goes up, so it tends to keep the readings more constant. Not a perfect circuit, but it does seem to work to some extent. Okay, well, let's move on to the next part, which I think is going. I've been setting up in preparation for calibration. The only calibration on this unit are those two pots right there. This near one sets the bias value, and the far one sets the signal value. Let me show you what that is on the schematic. The high bias is this minus 18 volts. And if you follow it over here and up to R9 there, that's the control I showed you earlier, that just a second ago, that sets the bias value. Basically, there's minus 150 volts here, and then a couple of resistors in series, and then a capacitor that provides some additional filtering, another resistor divider that when it's in the GM position, or actually any of the positions other than the shorts position, this switch is closed, connecting this side of the capacitor, which of course is essentially the ground, to the bottom of this divider. So the key voltage is the voltage here, minus 18 volts. And then that gets further divided down to about minus 8 and about minus 2.9. And the question that I had was what those values should be when it's calibrated. This is basically the values that I read. I'm sorry, not that I read, that I took off of this other schematic, which is the same 500 bridge panel. It's hard to read. This is a very poor copy. But but it did have voltages on it. It's the only one that did. So I had copied those over. But the problem is that nowhere in the literature or on this schematic could I find the other value, which is the value of what's called high signal here. Coming across from here, I'll show you on the better schematic that high signal is basically tapped off the 4-volt AC winding. Now, of course, remember, 4 volts, that's RMS value. And then there's a potentiometer across it. And so the setting of this determines basically the signal that's applied to the tube when you're measuring GM, that is, to the grid. So the way it works, of course, is the bias signal, the DC signal, and the AC signal are added together and applied to the grid. The bias signal sets the operating point, and the AC signal swings the tube above and below that operating point. So the key question was, what should be the value of the high signal? Now, in some B&K testers, it's 2.5 volts. And that's what I suspected for this one. But I didn't know for sure. So I went about it kind of backwards. What I did was took a tube that I knew what the transconductance was, because I've measured it on a number of other testers. It's a 12AQ5, and fortunately this tester has a setting that says if you want the true mutual conductance, you set it to that value, which in this case is 75, and this is the average mutual conductance, 13,700. Well, it turns out, after looking through a number of these tubes, I found one, that is a 12AQ5, that I could measure fairly precisely on a couple of different calibrated tube testers, and its GM measured 14,000. So that's close enough to that figure to use as a standard. And then I put it in this unit and adjusted until I got 14,000. Well, it turns out, remarkably, that if you look carefully on these pots, you see there was a calibration mark there and another one there. I don't know if those were put on at the factory or if those were later somebody who was calibrating the unit in the field. But nonetheless, they're very, very close to the values that I was using. Now, I moved these all around while I was testing and so on. But remarkably, when I wound up setting the values back to the bias values as shown on this schematic and to the signal value that I obtained by working backwards from that 12AQ5, they came out right where they originally were. Now, maybe I shouldn't have been so surprised, because one thing I noticed about this tester is that the resistors are remarkably close to their marked value. In fact, they're all well within 5%. So that shows that unlike a lot of old equipment, this particular piece of equipment, they use some pretty high quality resistors in here, and I was not required to replace any of them. They were spot on, in other words. Now, of course, I did replace capacitors and other things like that, but that surprised me. So anyway, what I have now done is I've calibrated the unit. I won't actually show you the calibration. I will sort of tell you on the schematic. It consists, of course, of measuring this point and setting the first pot to minus 18 volts, and then measuring this point and setting that to the negative 2.5 volts RMS. I think that's where I'll break off for now, because what I want to do is finish up some work I've been doing on the case for this unit, and then reassemble it in the unit and go through a kind of how to use this tester mode. So that's where I am, and that's where I'm going. Before I put this in the case, it occurred to me that there are a few kind of minor points that if you're working on these tube testers, you might be interested in these points. And I can only show them to you now before I put the thing in the case. So one of them has to do with these light bulbs. Not just these two, also the Shorts light there and the pilot light there, but it's really important for these two. And that is, these old bulbs, and especially these old sockets, are pretty unreliable. They corrode and so on. In fact, this socket came completely apart. And let me see if I have a socket here. And I'll show you kind of what happens. If you see that little crimp, this is one of these bayonet sockets. And this is a new one, but you see that crimp right there. Well, what tends to happen over time is that crimp corrodes, and the whole center of this thing can become loose and can fall away. Second thing is those washers in there tend to get hard and shrink with time, and that means that there's not as much pressure on those contacts. The result is that these become very intermittent. So you can replace them, which is a real problem in some cases because they don't really make a dual setup like that as a replacement, so you'd have to take one out of another tube tester, which it's probably, if they're old, it's probably bad too. My point is that what I did in this tester, and what I normally do when I have this problem, is I put a solder bridge between like the case there and the contact for the case. The reason is, otherwise the only contact between the tab there and the base is friction. And when those washers start getting loose, that friction disappears. So if you put a solder bridge in there and also put a solder bridge on this contact back here, then you get a much more reliable contact. Now, there are some people on the web and so on who actually recommend soldering the bulb into the circuit. I haven't found that necessary, but you might want to consider that also. Anyway, reliability of bulbs is a big issue. The second thing is, I talked a lot about the connector here. That pin numbering comes through this cable and is actually mirrored in the in this connector or this terminal strip. In other words, this is pin 1, pin 2, pin 3, and so on. Just as over here, this is pin 1, 2, 3, and comes down to here. And the reason that I bring that up is when you're testing the units, this seems to be a convention of B&K. Most of the testers of the period that had detachable panels, like this one and the 650, they have connectors like this that are numbered the same way. So it helps a lot if you know how that numbering is, because that way you can check voltages and resistance levels and so on quickly, and reference to the schematic. So that's kind of the points I wanted to make. The last point has to do with the sockets. Now, one of the biggest problems with these old tube testers is that they tend to have worn sockets. And the one thing you can do is you can clean them. What you can do is you can use deoxit or almost any good contact cleaner. You spray it in the socket. You can use small pipe cleaners or whatever. What I do is I just use one of the tubes. In other words, this is not a tube, it's actually an extender, but if you spray a little bit on the pins of the tube itself, and then plug and unplug it a few times in the socket. That will tend to remove most of the corrosion and oil and other things that are keeping it from making good contact. But the reality is these sockets wear out. And the only real solution to that is something like this. This is what's called a socket saver. And you mount it in the tube socket. The way it works is the pins that are on the bottom are just slightly bigger than the pins on a regular tube. So if the spring is gone in the contacts, which is often part of the problem, the socket saver, because it has slightly bigger pins, goes in and makes contact. And then you bolt that down, and from then on you plug into that socket saver instead. The big problem is that if the socket down below is in really bad shape, even socket savers won't fix the problem, and then you wind up having to replace the tube sockets. And of course, as you would expect, the sockets like this one, this is the most used socket on this tester because the most popular tubes are here. And that means that this will be the one that will wear out usually first. And the more times you put a tube in, the less spring the contacts have left, and therefore the quicker that it will wear out. So anyway, those are the things I wanted to say before I put this in the case. So I probably talked a little too long again, but next step will be putting this into the case and then showing you how it works from the top side. I've put the main chassis back in the case and reinserted this filler strip, and now the last assembly is to put the socket panel in, and of course I have to put the hinge pieces back on the rear. I'm not going to do them yet though, because they're obviously pretty rusty, and I want to get all of that rust off before I proceed with that. But otherwise this unit should be at least electrically complete. And so I'll show you a little bit about how it works and some of the things that you might need to watch out for on tube testers, at least the things that I've been taught by others and a few things I've learned on my own. So that'll be in the next segment, and that should be pretty much the end of this B&K500. I will leave the overhead lights off for a little bit because when I show you the shorts function, it's the only way you can really see that neon bulb well. Right now you can see that the neon bulb is not lit. I'm testing a 6F6, which requires a sensitivity of 95, and of course a filament of 6 volts. So you set the filament, sensitivity, insert the tube in the socket, and then turn the tester on here, which I've already done because you need to allow that tube to warm up a little bit. And then you go from the short position, that is if you don't have any shorts, you go to GM. Now by the way, if the shorts light is lit, don't move this switch. Keep it in the shorts position, because you can actually ruin the tube tester depending on the kind of short there is in the tube. So you don't want to go to any of these other tests if the short light comes on. Find the problem. If it's in the tester, fix that. If it's in the tube, throw the tube away. So now let's go to GM, and you see it tests as a good tube. The next thing is the life test. What the life test does is lowers the total voltage to the tester. So the tube filament runs cooler, doesn't emit as many electrons, and basically the idea is to see how close to the edge this tube is. So let's try that. And what should happen is if the tube is good, it'll stay right there. If on the other hand it's nearing the end of its life, that will start to drop off. Well, this tube I know is a good 6F6, and that's one reason I used it, and it did not drop. Now let's go back down here to the shorts position, and what I'm going to do is I'm going to plug a 1 meg resistor between pins 2 and 4 of this. And you'll notice down here what happens. The shorts light comes on. That is supposed to be the sensitivity of this tester, at least as best I can tell. There's no actual spec because there's no adjustment, but for the other B&K testers it's a meg. And once again, this is part of the calibration procedure for most of the testers, which you can find online. Unfortunately, you can't find one for the B&K500. So what I do is I use the calibration procedure from the B&K700, and it seems to be pretty close, except for the AC voltage, and that's going to vary depending on which unit you have, whether you have the one with the 6AX5 or the one with the Type 83. So I hope you enjoyed watching me work on this B&K500 and get it working again. It appears to be working in all respects and appears to be reasonably well calibrated. So if you feel like refurbishing a tube tester, this is one you might want to try. Be aware, however, that this tester only works with some of the very early tubes, that is, the tubes built up until about 1958. Anything after that, you probably should go to one of the later brands or later models of testers. So anyway, I hope you enjoyed it, and if so, maybe it'll inspire you to get out and try a refurb on your own tube tester. See you in the next project.